In 7.112, IB wants us just to be able to state or say, and I've seen in past exam questions that they'll give you a piece of DNA and they'll ask you what would be a good one for using in something called DNA profiling. So let's just talk about DNA profiling first. So DNA profiling, just change the color here. DNA profiling is a lot like what we did before when we were looking at how we determine the different bases by using different lengths of DNA. So in this piece of equipment called a gel electrophoresis, we can put different segments of DNA in here. And so maybe this is sample A, sample B, sample C, and sample D. And they use gel electrophoresis for DNA profiling for like a crime scene, or maybe they want to figure out who the real father is. And so individual A might be a suspect, individual B might be a suspect, individual C might be a suspect in a crime. And in this section right here might be blood we connected from the crime scene, or maybe it's a piece of human hair where we can get DNA. And then we run it through this machine, and depending on where the DNA stops, based on length, we can determine what it matches with, and we can figure out who the murderer is. So let's look at my example for a second. So remember, so DNA is going to travel down this way towards the positive end, and the shorter DNA is down here, and the longer DNA is up here. So if we looked at this gel electrophoresis, we could see that the DNA lengths here match the DNA lengths at the crime scene, and we can conclude that suspect A was the murderer, for example. So that's why we use DNA profiling. But why is this? Why are there different lengths of DNA? Aren't we all human? Don't we all contain the same 25,000 25,000 genes? So yes and no, right? Like some of the basic genes that we have for making insulin and all the different enzymes that help we digest, all of those genes, yes, they're the same. Some differences would be things like hair color, eye color, genes that control your height. So those are small differences there, but the best differences are in these things called tandem repeats. So tandem repeats are sections of DNA. So let's get a piece of DNA here. I'm going to draw let me just make a double helix first. And then I'm going to make a different color here just to identify something. And then I'm going to go back to green. And I will say Y in a second. So here I have a section of DNA. You may have heard me say this before, but DNA, only 1.5% is used to code for genes. So only 1.5% of your entire genome actually makes a protein. The rest of it, some of it we have ideas what it does, some of it we're not really sure. So for example, the beginnings might identify where we want to begin to read that piece of information. But what is all of this space? This space up here also is made of repeating sequences, right? Can you see GATA, 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 and it can just go on and on and on and on for much more than 10 repeats. Sometimes it's thousands of repeats like that. So tandem means together, and they repeat often. This is what makes our DNA different, because individuals have different types of tandem repeats and also different lengths of these repeats. So this is how we can get different lengths of DNA. So if we looked at this participant number 4 down here, he or she has 10 repeats, right? where participant 1 has 8, so that would mean that the DNA would stop at different distances along this gel electrophoresis.